Hello everyone, welcome to AA Academy. Today we'll going to discuss about some theory concept. You can call that as a derivation or else relationship between delta star transformation. Means that how can convert from delta connection into star connection. That is transforming delta into star. First, we should know how we are getting that formula of delta star transformation. That is nothing but the derivation of star delta transformation. It is very important because if you know how you are getting that expression or its formula, then only can able to remember the conversion techniques. Okay, so what I will do now, so take uh, I'll just consider some delta connection or else a simple delta connection. You can see here, so z or else r, whatever you can take. If it is DC supply, we'll be considering only register R. Suppose if it is a AC, you can consider that as a Z. So that for say, by considering on the both sides, I'm considering this as impedance. I'm naming this as ZA, ZB, ZC. This is the delta connection. You can consider one node one, and here it is a two, and this will be three. So this delta connection, we need to convert into a star. So that is nothing but once after converting, the circuit will be looks like this. That is for a star. So I'm just naming this as Z1, Z2, and Z3. Whatever the notations you can give, nothing to worry. Okay. So we need to get this expression of Z1, Z2, Z3 with the help of ZA, ZB, ZC. That is nothing but transforming delta into star. So let us start the derivation without wasting time. So for this, so you can consider any two of node. You can see this figure one I can give here. This figure one is having three nodes. That is nothing but node one, two, three. So I'll considering any two nodes by opening third node. For example, consider node one and two by keeping node 3 as open. By keeping node 3 as open. So this node 3 is open. So which means that the circuit which looks like this or is the connection diagram which looks like this. So I am removing this. So if you are removing that means what will be the expression 1 and 2 together? That is nothing but I'll write as at node 1 we'll be having Z1 and Z2. So node 1 and node 2 together, Z1 and Z2 together. So how we'll get this equivalent circuit now? See now here, ZA and ZC are series. This combination is connected in parallel with ZB whenever if you're considering node 1 and 2, that is nothing but ZB is parallel to ZA and ZC. Both are in series, so that I'm writing ZA plus ZC. So if you simplify this, you'll get like this Z1 plus Z2 equals ZB into ZA plus ZC divided by ZA plus ZB plus ZC. It is a normal parallel combination reduction. If two resistors are in parallel, R1 R2 divided by R1 plus R2. Like that, ZB and ZA plus ZB are in parallel, so that ZB into ZA plus ZC divided by ZA plus ZB plus ZC. Similarly, the same thing you have to consider for another two cases. What are the two cases? So the next case is 1, 2 you are considered. So I'll be rewriting now. Consider node 2 and 3. Consider node 2 and 3 by keeping node 1 as open. By keeping node 1 as open. So it is nothing but again you can observe the circuit which looks like this. That is nothing but considering 2 and 3, and this node 1 is open. So I can now easily understand the concept. If node 1 is open is nothing but how we can write now? If node 1 is open, ZA and ZB are in series. And this combination is connected parallel to the ZC if you are considering 2 and 3. That is nothing but Z2 plus Z3. Node 2 and node 3 together will get expression that is ZC is parallel to the series combination of ZA and ZB. That is nothing but you will get expression as ZC into ZA plus ZB divided by sum of all impedances or resistances, that is ZA plus ZB plus ZC. This is equation number 2. Similarly, now we can consider another case. What is the another case now? So the another case is by considering next two nodes by keeping other nodes as open. You can see now I'll consider the next case, that is nothing but I'll rewrite as it is 1. This is 1. So 1 2 we consider, 1 2 we consider, 2 3 we consider. Next node 3 and node 1, we can call that as either junction 3 and junction 1. I'll write here node 3 and 1 together, or else 1 and 3 together by keeping node 2 as open. By keeping node 2 as open. So which means that you can rewrite the expression like this. Node 1 is considered, node 3 is considered, but node 2 is not considered, so that it is open now. So if node 2 is open means again how can you write the expression, that is 3 and 1 together, Z3 plus Z1 node together you will get again ZB and ZC are in series. This combination is parallel to ZA. So that can write ZA is parallel to ZB and ZC. So if you rewrite this expression, you can get again ZA into ZB plus ZC divided by ZA plus ZB plus ZC. This will be equation number 3. So I hope you got to know now. So by considering all the three nodes, initially it is 1, 2, then it is 2, 3, then it is 3, 1. So you can see now the expressions equation 1, 2, 3 here. I hope you are seeing the equation 1, 2, 3. You can consider this. So by considering this again, I'll rewrite for your reference. There will be delta connection. There will be delta connection. Sorry. So there will be delta connection. Again, I'll consider one delta connection like here. There will be delta connection. So you are converting or else you are transforming this delta into star. That's nothing but ZA, ZB, ZC. You are writing in the form of Z1, Z2, Z3. That is nothing but in this form Z1, Z2, Z3. By considering all the three nodes 1, 2, 3. This is your Z1, Z2, Z3. Either you can give clockwise or anti-clockwise, that is up to you. Writing notation is your way, but you should understand the process or steps to derive the transformation equation. So once if you are getting this equation 1, 2, 3, so next let's do some simplification. So what I will do, so I'll subtract equation 1 and 2. 1 minus 2. I'm subtracting equation 1 and 2. So what is equation 1? Z1 plus Z2. Z1 plus Z2. What is equation 2? Z2 plus Z3. That is you are subtracting, so that minus of Z2 plus Z3. That is equal to the same all expressions I am writing. So what is Z1 plus Z2 expression? So here Z1 plus Z2 is nothing but ZB into ZA plus ZC divided by ZA plus ZB plus ZC minus of Z2 plus Z3. Z2 plus Z3 is nothing but minus of, we can observe here Z2 and Z3 expression, that is equation 2, that is ZC into, we'll rewrite again, ZC into ZA plus ZB divided by ZA plus ZB plus ZC. You should solve parallelly whenever explaining in the video, then you can easily understand the expression. So now here you can see, rewrite again. So plus Z2 minus Z2 will get cancelled. Before that I'll simplify. So I'll simplify the expression. So it becomes Z1 plus Z2 minus Z2 minus into plus is minus Z3 equal to, denominator is same, I'll write as it is, that is ZA plus ZB plus ZC. So again I'll simplify the numerator, it becomes ZA ZB plus ZB into ZC, ZB into ZC minus of ZA into ZC, again minus into plus minus ZB into ZC. You can see again, you can observe the expression. So for this expression again you can see now plus Z2 minus Z2 will get cancelled, plus ZB into ZC, that is this term, plus ZP into ZC minus ZB into ZC will get cancelled. So what you will get by cancelling this, you will get Z1 minus Z3 on LHS, that is given by ZA ZB rest of the term minus ZA into ZC divided by ZA plus ZB plus ZC. This is equation number 4. So now we can see all the expressions, equation 1, 2, 3, 4 together. So I'll just minimize this to understand the expression. You know, equation 1, 2, 3 together. Once again, okay. So now we can clearly visible. So by considering 1 and 2 can get equation 1, equation 2, equation 3. So by just simplifying equation 1 and 2, that is subtracting equation 2 from 1, you'll get Z1 minus Z3. So now we can see equation 3 and 4. So further simplification I will do, that is nothing but the next step. That is nothing but now I will add equation 3 and 4. I will add equation 3 and 4. Equation 3 is Z3 plus Z1. I'll read it again. Z3 plus Z1 is equation 3 plus 4. Equation 4 is this, that is Z1 minus Z3. So this will be our equation number 4. That is nothing but plus Z1 minus Z3 equal to adding all the 3 and 4 on right side also. That is nothing but I'll multiply this here itself. That is nothing but ZA into ZB plus ZA into ZC. Again on fourth equation, adding, so that plus ZA into ZB minus ZA into ZC divided by denominator. The same thing, ZA plus ZB plus ZC. So now again what I will do, I'll rewrite this equation. So before rewriting, observe the equation, which term we cancel. So here you can see minus Z3 plus Z3 will get cancelled. Here also plus ZA into ZC minus ZA into ZC will get cancelled. The rest of the equation, Z1 plus Z1 is nothing but 2Z1 equals to ZA into ZB plus ZA into ZB is nothing but 2ZA into ZB divided by ZA plus ZB plus ZC. 2 and 2 will get cancelled. You'll get expression of Z1. It is nothing but once after while converting delta connection into star connection to get the star arms. For the first arm, you should get, if you want to get Z1, you have to use this expression, that is ZA into ZB divided by ZA plus ZB plus ZC. So to remember this expression now, to remember this expression, so I'll redraw once again the delta connection network. That is nothing but there are three arms you can see. That is nothing but ZA, ZB, or else ZC, whatever you can consider. So these are the three arms. So I will rewrite here. Sorry, I'll erase once again. Note, okay, arms like this. So here, one, second, third node. So this is ZA, ZB, ZC, delta connection. Or else you need to transform this delta into star, that is in this form, in the form of Z1, Z2, Z3. This is Z1, Z2, Z3. So now how we are getting the Z1 expression? See now, observe the Z1 expression. So Z1 is given by ZA into ZB. See this arm, the Z1 is connected to node 1. That is at the node 1, what are the impedances you are connected? ZA and ZB. In between Z1, observe, in between Z1, ZA and ZB are connected. So that I'll write ZA into ZB divided by sum of all the arm impedances or resistances, that is ZA plus ZB plus ZC. So if you consider at node 1, you can observe here. So here ZA is connected, ZB is connected. ZA, ZB for first arm to get this Z1. So that ZA into ZB divided by sum of all the this ZA, ZB, Z for first term. Similarly, if you want to write Z2 and Z3, similarly for these two expressions Z2. So to write the Z2 expression again, you can observe. Okay, so I'll rewrite now. Z1 here. Z1 already written. To write this Z2. So Z2 you are connected at node 2. At node 2, what are the impedances you are connected? ZC and ZB. So that you can write Z2 equals in between. That Z2 is connected in between ZB and ZC. So that Z2 is given by ZB into ZC divided by ZA plus ZB plus ZC. Similarly, Z3 you will write. Z3 is given by, see now Z3 is connected between ZA and ZC. So that ZA into ZC divided by ZA plus ZB plus ZC. To understand this, I'll take one simple example. For example, there is a delta connection of three resistors. Say it as, I'll write now. There is a delta connection like this. So I can give here A node, B node, C node, and there are three resistors. Say it as some 5 ohm resistor, 6 ohm resistor, 7 ohm resistor. You need to convert this delta into star. That is nothing but in the form of R1, R2, R3. In this form, you need to convert. That is, for example, this is R1, this is R2, this is R3. So how will write to get R1? R1 is connected between 5 and 6. So that R1 you can write. Suppose I'll rewrite again. RA is 5 ohm, RB is 6 ohm, and RC is 7 ohm, for example. Suppose if we're giving notations. So if you want to get this arm, that is R1. So see now R1 is connected in between, that is nothing but in between R1 is connected in between 5 ohm and 6 ohm. So that you can write R1 equals to 5 into 6 divided by sum of all the resistors. 5 plus 6 plus 7. Similarly, how will write R2? R2 is connected in between 6 and 7. This is your R2 is connected between 6 and 7, so that 6 into 7 divided by 5 plus 6 plus 7. Sum of all the resistors or else impedances if you're having. R3 how will write? R3 is connected in between 5 and 7, so that 5 into 7 divided by 5 plus 6 plus 7. So like this you have to convert. So once after getting these values, so this delta is converting into star, that is R1 the value, R2 the value, R3 the value. So like that you need to solve the problem. Anyhow, the problems related to delta star transformation we'll discuss in next video. Just have some idea how we can solve the expression. That is how we are getting the expression to write the transformation. If you want just a glance, so consider this. Just a glance now. Consider the delta connection. It is having three arms called as ZA, ZB, ZC. So you have to convert this ZA, ZB, ZC in the form of Z1, Z2, Z3, so that consider any of two nodes by leaving third node, so that consider one and two nodes. So to consider this, leave third node now. So if you leave the third node, so again the circuit which looks like this, that is third node is open. ZA and ZC are in series, so that you can write Z1 plus Z2. One and two nodes together will get ZB is parallel to ZA and ZC. Similarly, if you want to write in between 2 and 3, 1 is open, ZA, ZB series, ZC is parallel. Similarly, 3 and 1, 2 is open, ZB and ZC are in series, ZA is parallel. You'll get three equations. Then you can take any of the two equations, you can subtract any of the two equations. For example, I'm considering 1 minus 2. You will get one more equation, that is equation 4. Then you can add that related. See now Z1 minus Z3. So we'll be having Z1 plus Z3, so that I'm doing 3 plus 4. Adding equation 3 and 4, you'll get Z1. Similarly, once after getting Z1, no need to derive for all Z2 and Z3. So you can write with the help of this diagram. If you want to write Z1, in between Z1, ZA and ZB connected, so that ZA, ZB divided by ZA plus ZB plus ZC. Similarly, in Z2, Z2 is connected in between ZB and ZC, so that ZB, ZC divided by ZA plus ZB plus ZC. Similarly, Z3 is connected in between ZA and ZC, so that ZA into ZC divided by ZA plus ZB plus ZC. So this is how we have to remember the delta to star transformation. Similarly, I'll explain in another video star to delta transformation, the derivation. So later we'll solve some problems related to star delta transformation as well as delta star transformation. So I hope you are understanding the concept of delta to star transformation. So if you like the video, please do subscribe, and also if you are having any doubts, you can post that in a comment box. Thank you once again for watching this video. So I hope you like the video. So share as much as possible support to the video. Thank you one and all. Have a nice day.